Today we are going to look at dividing some polynomials by a monomial, and then also a little bit of review of multiplying and dividing rational expressions. So let's take a look at our first problem on page 671. We have 1 through 6 all, and the problems look similar to these. And so all you're going to do when we're dividing by a monomial, which is just one term, is we're going to take each of the terms in the polynomial here and divide them by that one number. And so here, I'm going to just rewrite this as 15c to the third over 3c and 3c to the second over 3c. You're just going to divide each of the terms by this monomial and then reduce the fraction. And so you see that 3 goes into this 15 5 times. So we have 5 left over. And then this c will take out one of the c's down on top, and we're left with 2 c's on top. So 5c squared is what we get there. Here the 3's cancel out, and this c goes into this c just one time. So we have plus a c, and that's it. 5c squared plus c is what you get when you do that division. So it's the same thing with all of them. You're just going to rewrite this polynomial here that we're dividing into, and we're going to put the 4b, which is our divisor, underneath each of these terms, and then see what's left over. And then rewrite the polynomial with whatever's left. So here the 4 goes into this 20, we have 5 times. b goes into b to the fourth, well, we have 3 b's left on top of the fraction, so 5b to the third power. Here the 4 goes into this 12 3 times, so it's going to be a minus 3, and these b's cancel out, so just a minus 3 is all we have. Here these 4's cancel out, so we're left with plus 1 over b. Notice that the b's left on the bottom, so that's why I wrote that as a fraction. And that would be our answer. Taking a look at the next one, the same sort of thing. You're just going to rewrite these as separate fractions. 9q to the fifth goes underneath each of these terms because we're dividing each of the terms by that 9q to the fifth. And so we go ahead and do that division. See what's left over here. So 9 goes into this 27 3 times. And these 5q's cancel out 5q's on top, leaving me with 1q. So I have 3q. Over here, this 3 goes into 9 3 times. So far I have 1 over 3. But let's see how many q's are left. Well, these 3 q's are going to disappear on top. Taking away 3 from the bottom leaves us with just 2 q's on the bottom. So 1 over 3q squared. And then plus, and then we go ahead and do this work. Here we have 9 goes into the 18. We have 2 times, so we have 2 on top, q to the fifth on the bottom of the fraction. And that is our answer right there. Same scenario in all these. We're just going to divide by the divisor. So you treat it as separate fractions, and you see what's left over. So let's take a look at our first one here. We've got 15 goes into the 15 one time, and these 3 t's are going to cancel out 3 of the t's on top, leaving us only with this 1 t. And then over here we have 15 goes into 32 times, so make sure you write that as a negative 2, and then you count how many t's are left over. See these 2 t's here, we're going to cancel out 2 of the t's on the bottom, leaving us only with 1 t on the bottom of the fraction. And then over here we have the 6 and the 15. Well, there's a common factor of 3, so you're going to divide them each by 3. So you've got 2 left there, and we've got 5 left on the bottom. And so it's just going to be a plus 2 over 5t. And that would be our answer. So let's take a look at the next few problems here. So the first one is a multiplication problem, and that you just treat this as a fraction. The second part here is a fraction, and remember with multiplication you want to factor. And so we'll start with the 2m, that's going to be on top of the fraction, and here we have m squared minus 16. It's a difference of squares, so it's going to factor to a sum and a difference. So there's my difference, and here is my sum. And so down below, we just rewrite what we have, but in the factored form. So you're going to take out a common factor of 5 to start with. So when you divide by 5, you see what's left over. We've got an m plus 4. And so from that point, we can just take out those common factors of m plus 4. They disappear, and what's left over is a 2m times by m minus 4. So that's in the bottom of the fraction, or top of the fraction. Down below, we just have the 5. Now, I would let you leave this as your answer for a test problem. Now, if you see, sometimes they'll have multiple choice tests with where they don't leave it in the factor form. They go ahead and multiply what's left over. And so that would end up being 2m squared minus 8m all over 5. So either of these answers are good with me. And looking at the next one here, another multiplication problem. So let's go ahead and rewrite what we've got in the factored form as one fraction. So here we have a p plus 3, which I just brought down, but over here we have a common factor of 3. So take out that common factor, put it on the outside of a parenthesis, do the division, see what's left over. P minus 5 is what we get when we take out that common factor of 3. P squared minus 25 is going to factor as two binomials, p minus 5 and a p plus 5. And then from there we can go ahead and take out the common factor here. Well, we don't see one, so it's just going to be two binomials. And so if you see a quadratic and no common factor, try factoring as those two binomials. P plus 3, p minus 2 is the way that factors. Numbers multiply to make negative 6, but subtract to make positive 1. Well, you go ahead and take out those common factors. In this case, the p minus 5's cancel, and the p plus 3's. So all we have left over is a 3 on top, a p plus 5 multiplied by a p minus 2. If you leave it like that, for me, I'm fine with it. Or you could go ahead and multiply out the denominator, and if you did, you'd end up with a p squared plus 3p minus 10. So either of those answers are good. Next one is just a monomial divided by another, actually not even a monomial, just an expression with variables and divided by another one. And not a monomial because you don't divide by, when you have a monomial, you don't have denominators with variables in them. So here we go ahead and just simplify what we've got. Now, when I do this, I'm going to rewrite this as a multiplication problem. And when I do, I'm going to take the reciprocal of that second fraction. So it becomes x to the fourth y over 3z to the fifth, and then I'm multiplying by 9y squared z, and this is all over this x squared z to the third power. And so I'll go ahead and rewrite this now as one fraction, and always use that commutative property. When you don't have any addition signs, you could go ahead and do that. We've got x to the fourth. Looks like we've got 3 y's on top. 1 y and 2 y's make 3 y's, and then that z. Down below we've got the 3 and x squared and no y's, but we do have 8 z's on the bottom. And so now we can go ahead and take out those common factors. And so we see that 3 goes into the 9 3 times. And the x squared is going to cancel out 2 of the x's here, leaving me with 2 x's. And then here I have 1 z taking away this, one of the 8 z's on the bottom, leaving us with 7 z's on the bottom. So let's rewrite what we've got. 3x squared, y to the third, that's on top. Down below we just have z to the 7th power. That is our answer. Well, this next one, again, you treat this as a fraction, and we're going to change it to a multiplication problem. Now, as we do that, let's try factoring. And so let's take out a common factor here of 8 to start with. And so we'll put the 8 outside. We've got an n squared minus 1. Now that's a difference of squares, so that will factor a little further. Here we have just the 1 on top now. Now here we have a common factor of 10n. So we take out that 10n, put that outside the parenthesis. We do the division. We're left with a 1 plus n. And that's it, or n plus 1. Here there's a common factor of 2n. So let's take out that 2n from each of these terms. Divide them all by 2n. And this is going on the bottom of the fraction now. Notice how I'm taking the reciprocal here. And so 2n goes on the outside. And when I do that division, I'm left with an n squared plus 3n and then minus 4. And so now let's go ahead and factor another time here. See, on the top now we've got an 8 and then multiplied by n minus 1 and an n plus 1. Then down below, we've got this 10n, and it's being multiplied. I'm going to change the order here, n plus 1. And then I've got that 2n still, and I also have a quadratic that will factor as two binomials. It'll be n plus 4 and an n minus 1. So now we can go ahead and take out those common factors. We see the n minus 1's canceling out, n plus 1's canceling out. And what else do we have? Well, let's see here. 4, 2 goes into the 8 4 times. And then also 4 and 10 have a common factor. So this could become a 5 and this a 2. So let's see what's left over. We've got a 2 on the top. Down below we got 5n squared. See, there's one n and two n's make n squared, multiplied by an n plus 4. And that's the answer. Now if you multiplied that out in the denominator, you could also have 2 over 5n to the third plus 20n squared. Either of those answers would end up doing fine. So those are the types of problems that you'll see on tonight's homework. Good luck.